This basically explains how the graph of current against potential difference in the filament lamp will look like, which is called the IV characteristics of a filament lamp. Then quickly we move over to the next one, which is for a semiconductor diode. A diode is a rectifier. A diode. The symbol for a diode is like this, which means a diode only conducts when the voltage is applied in the forward bias. A diode only conducts when the voltage is applied in the forward bias. So we can easily say here that a diode is a rectifier. A diode is a rectifier. It only conducts when the voltage is applied in the forward bias. That is like this. When the voltage is applied in the forward bias, that is when the diode conducts. Meaning that this end is positive and this end is what is negative. If you apply the voltage to make this end the positive polarity and this end the negative polarity, that is when the diode will conduct. If the voltage is reversed, for example, look at this. So we said that a diode only conducts when the voltage is applied in the forward bias. Meaning that this end is positive and this end is negative, so the diode conducts. But when the voltage is reversed, meaning that this end is negative, this end is positive, the diode will not conduct. The diode only conducts when the voltage is applied in the forward bias. Okay? That is when the diode conducts when the voltage is applied in the forward bias. So as the need voltage or as the inbuilt voltage is exceeded, current increases with voltage. Okay? Hence, heating effect also occurs. And temperature increases, which causes resistance to do what here? To reduce. Note that it's a semiconductor, and as temperature increases, resistance will reduce. This is only applicable in the forward bias. Hence, in the reverse bias, the diode will not conduct. The diode will not conduct. So we can say that the resistance of a diode in the reverse bias is infinity. Know that. So I can easily sketch that now. So if I then plot the graph of I against V for a diode, it will look like this. The graph of current in amperes against the potential difference in volts. As the PD is increased and the inbuilt voltage is exceeded, the diode will conduct. So this is called inbuilt voltage V0. The diode will conduct. Now you see that the diode is also, it is not a ohmic conductor. Because as the PD increases, the current also increases. And the heating effect increases. So the resistance will increase. And and the heating effect increases, hence the temperature will increase. But because the diode is made up of a semiconductor, as the temperature of a semiconductor increases, its resistance reduces. And the resistance here represents the inverse of the gradient of the graph. So if the resistance reduces, the inverse of the gradient of the graph will increase. That's why you can see that the gradient of this graph here shows an increasing gradient, which shows that the conductance is increasing. The conductance is the gradient of the graph, and the resistance is reducing. And when the voltage is then applied in the reverse bias, the diode does not conduct. So that means the conductance in the reverse bias is 0. Resistance is what? Is infinity. So you can note that inverse of resistance is what? Is conductance. That is what explains that.